Welcome to the first introductory tutorial to plant simulation. Plant simulation allows you to model, simulate, explore, and optimize logistics systems and their processes. These models enable analysis of material flow, resource utilization, and logistics for all levels of manufacturing planning, from global production facilities to local plants and specific lines, well in advance of production execution. This tutorial will demonstrate how to easily set up a production line with the source producing parts, which are then processed by 3 machines and lastly removed by a drain from the plant. First, you need to start plant simulation. This will open up the main menu. Here, several options are available. The leftmost column offers the options to either open up a previously created model or to create a new one. Next, the middle column offers information on how to get started with plant simulation. Here you have example models to get started with, video tutorials like this video, a quick start guide in written form, or new features that have been introduced in the latest version of plant simulation. In the rightmost column, additional helpful links are available. The first will open up the main page of the Technomatics Plant Simulation community, a forum for beginners and experts alike to exchange knowledge about plant simulation. And lastly, a link to the web page of plant simulation. To get started with a new model, click Create New Model. Now we will begin the model setup by inserting the objects we need. These are a source object, 3 stations, and a drain object. To do so, move the mouse over the source object in the toolbar. To insert the source object, select the source object, move the mouse to the location in the frame where you want to place the object, and click the left mouse button once. This will insert an instance of the source object. Next, select the station object in the toolbox and again move the mouse to the location in the frame where you want to place it. Now press the Control key to preserve the selection of the station in the toolbox. This allows to insert several instances of the station object. Finally, select the drain object in the toolbox and place it in the frame. Next, we connect the objects so that the parts can move from station to station. To connect several objects one after the other, select the connector in the toolbox and hold down Control key while clicking on the objects in the frame. To terminate Connect mode, click the right mouse button once or just press the Escape key. To make adjustments to the layout of the plant easier, it's also possible to switch to the planning view. This can either be done by selecting the planning view on the ribbon tab view or simply by pressing the P key. Now we see the grid from the top. To switch off planning view mode, simply press the P key again. Before we start the simulation, double-click on the event controller and click on the tab settings to define a time at which our simulation will be finished. In this demo, the simulation duration is set to 1 day. The first 2 numbers define the seconds, the next 2 the minutes, the next the hours, and finally the days. Click OK to save the changes. Now we are ready to run the simulation. To do so, click Reset and Start on the Home ribbon tab or press the right mouse button to open the context menu and start the simulation. To run the simulation faster or direct to the end, press the Start Fast Forward Simulation button. Next, check the results. Double-click the drain object to open its dialog. Select the tab type Statistics to see the most relevant statistic data of the produced parts. On this tab, we see the average lifespan of the products, the total throughput, and for example, the throughput per hour. Naturally, you want to view statistics of the stations. Double-click a station and change to the tab Statistics to have a look at their most relevant statistics. To have the throughput of your plant shown to you in a convenient manner, you can use the Display object. Select the Display object in the Toolbox user interface. Move the mouse to the location where we want to place it and click the left mouse button once. Then drag the drain object over to the display object and drop it on the display to have the total throughput of the plant visualized. As you can see, the total throughput for one day is about 8,637 parts. You can also present the results of the simulation graphically with the chart. Select the chart object in the toolbox. Move the mouse to the location where we want to place it and click the left mouse button once. First, select the material flow objects whose data you want to show. Drag the selection over the icon of the chart and drop it there. As we want to show resource statistics of the objects, we click OK in the Dialog Statistics type. The chart shows that the stations were working all the time. This is not very realistic though, as machines tend to fail in a real plant. To simulate a more realistic situation, let's use an availability of 90% for all stations. To do so, it is not necessary to change it in every instance. You can change it directly in their class. To do so, double-click the station in the toolbox to open the class of the station. Next, navigate to Failures tab. Click on the New button to define a new failure. Plant Simulation has predefined values for availability and mean time to repair, abbreviated here to MTTR. Enter 90 for the availability of the station and 5 seconds for the mean time to repair. When you click Apply, Plant Simulation automatically enters the corresponding interval and duration. Next, click OK. When you open the dialog of the station, you see that they inherited the settings of their class. Finally, reset the simulation and run it again in the full speed simulation. When checking the resource statistics chart, we see that in addition to working, the stations now also failed, blocked, and waited. Due to the fact that the following machine has disturbances, a finished part cannot be immediately forwarded to the following machine. Also, the total throughput for one day is decreased to 6,600 parts. To reduce blocking times for machines in production lines, buffers can be used. To do so, insert a buffer between the stations and adjust the connectors. The buffer not only tides over failure times, but also serves as a compensating station for fluctuating transport and operating times, which lead to queues forming in front of a machine or a component. Next, insert a chart again and drag the two buffers over the icon of the chart, then drop it there. As we want to analyze the occupancy of the buffers, we click OK in the Dialog Statistics type. The occupancy of the buffers help us to decide how high we need to set our buffer capacity. The buffer capacity can be changed in its dialog, and it is set to a default value of 8. Change it to 100 to observe the maximum buffer capacity usage. This assists in determining the optimal buffer capacity while preventing excessively high capacity, which is linked to increased costs. Reset the simulation and start it again. Open the chart of the buffers again. As we can see, the highest occupancy is about 59 parts, which only one buffer reaches. The highest occupancy of buffer 1 is about 15. The total throughput is 7,736 parts. The chart shows us that a capacity about 15 will be enough to produce nearly the same amount of parts like before. To do so, reset the simulation, change the capacity of the buffer to 15, and start the simulation again. You can control the simulation speed on the event controller. As we can see, the total throughput is 7,733 parts, which means that we can produce 3 parts less, but reduce the capacity from 100 to 15. When examining the resource statistics chart, we observe that the blocked and waiting times decrease as a result of the buffers we have implemented. This concludes the first introduction to plant simulation.